Okay, this problem reads, listed below are the amounts of mercury in parts per million, or ppm, found in tuna sushi sampled at different stores. The sample mean is 1.04 parts per million, and the sample standard deviation is 0.33 parts per million. Use technology to construct a 90% confidence interval estimate of the mean amount of mercury in the population. Okay, so we're given the raw data. Now, we need to first verify that we can even use the t-interval. In order to use t-interval, we have 1, 2, 3, 4, 5, 6, 7. When we have a small sample size, we need to verify that it could have possibly come from a normal population. And we do that by opening this up in StatCrunch. I'm going to open the StatCrunch. And we're going to create a probability plot, or a QQPlot. So we're going to go to Graph and go down to QQPlot, select the variable, and then just click Compute. And these dots need to be relatively straight, and these are good enough. So it's kind of like reading tea leaves. It is subjective, but so long as there are no major departures from this linearity, we're okay. It may be good if and you've probably seen examples in the text and in maybe some instructional videos where the dots went way off. Maybe if we had one, it kind of just curved up completely. The pattern here, the line, the dots are sort of behaving. They're moving along this line, kind of bouncing around the line. So we're okay with that. Okay, so let me close that out. So it's also good if you will create BoxPlot. So do BoxPlot. Allows you to measure for symmetry. I like my BoxPlot to be horizontal. That's just me. So I'm going to change this to horizontal. So we're okay here. If we had a really wild-looking BoxPlot with outliers, on one end in particular, really skewed, we would begin to question, could this have come from a normally distributed population? But nothing alarming here. So we can go ahead and proceed with the t-test. So we're going to go to t-interval. T-stats, one sample, and now we actually have the raw data. So I'm going to click with data. Select the variable. We're doing a confidence interval, and I've forgotten what level. Let me pause it. Okay, it actually reads a 90% confidence level, so I changed the confidence interval to 90%. And notice if you want to, you can go ahead and run that, and then run a QQPlot along with that, and as well as box plots and dot plots and histograms. We're just not going to do that. We've already done the QQ and press compute. And here's my confidence interval. Round to 3 places as needed. So our confidence level would be, we've got 0.798 and 1.282. And there we go. Let me show you how to do this on the TI-83 or 84. Okay, so I'm going to press Stat, Edit, and I'm going to put a list in. I already have a couple lists in here, so I'm going to clear out L1, and then I'm going to clear out L2. So press clear, then press enter. Okay. Okay, so I went ahead and put the data in L1. You know, this is rounding, so I'm going to change that. I must have that rounded. Change that back to float. Then go back to stat and edit. And there we go. So I don't want that extra 0 there if I don't need it. Now let's go ahead and press stat. Stat, test. And we are doing a t-interval, so number 8. This time, though, I'm given the raw data. So select data, and make sure your list, it's in L1, right? So let me go back. If I went back to stat, the list would be in L1. If it's in a different list, change it to a different list. Frequency is going to be 1 in here. And then my confidence interval is 90%, so 0.9. Press enter. And we get the same thing, 0.798 and 1.282. It also gives us the mean at 1.04, and it gives us the standard deviation of that sample. It tells me n equals 7, so little checks along the way. Hope that helps. Okay, there is a way to do the QQplot on the calculator. It's called a probability plot. First do second y equals, and we're going to turn this on. So select plot 1, turn plot 1 on, and scroll down, and it's going to be the very last one. Okay. My list is in L1, leave data axis at X, and the mark of a little square is fine, and if you have a color chance, you can leave it blue. Then to graph it, press zoom, and we're going to choose zoom 9, zoom stat. That generally does a pretty good job. And here we're looking at, so long as these, are approximately linear, and again, that is somewhat subjective. You kind of know it when you see it. So that's how you do that same plot on the TI-8384. Hope that helps.